The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah. Turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry, observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalts. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, is it right to look for threats from space or artificial intelligence? So we're moving to 66 million years ago in the world where dinosaurs lived. What are we doing here? We're just watching these giant reptiles and waiting for one of the most massive disasters on our planet to strike. Right now, a giant asteroid bigger than Mount Everest is flying at a tremendous speed, exceeding the speed of sound 40 times in the direction of our planet from the depths of space. It passes through our atmosphere, heats up, and hits the coastal part of the island of Yucatan, which separates the Gulf of Mexico from the Caribbean Sea. The enormous release of energy destroys all living things in the area, on land and in the ocean. The air over the island is filled with smoke and ash. Yucatan Island has taken the brunt of the blow. The blast wave instantly turns the green territory into a giant, lifeless crater. The asteroid fell at the wrong time. By the moment of the catastrophe, Earth had already been undergoing devastating changes. Continents were separating from one another, and some volcanoes were waking up, pouring lava onto the ground. Dinosaurs had been almost on the edge of extinction, but the asteroid shaped their fate. Now, Yucatan looks like a giant funnel of melting rock. There are no more dinosaurs here. But what about those animals that were far from the crash site? The noise from the explosion was so loud that pterodactyls hanging out far from the crater flew up into the sky in fear. A Tyrannosaurus got distracted from its hunting and ran away as far as possible, along with Triceratops. But somewhere, even further, in mainland Mexico, ancient lizards continued to chew grass and run around fields. They did notice a bright flash, but didn't mind it. They didn't even hear the sound of the explosion because the sound wave dissipated in the air. No blast wave, no earthquake, and no meteor shower. Dinosaurs continue with their lives. Unfortunately, not for long. Most dinosaurs would have survived if the meteorite had fallen in a field, ocean, or any other place. Perhaps today we would see them in nature reserves, but the meteorite fell in the most unfavorable place. According to studies, the giant rock had a 1 in 10 chance to destroy dinosaurs, and it took this chance. It wasn't a soft landing. The stone didn't slip on the ground, but hit the rocky terrain like a giant hammer. The catastrophe wasn't limited to a blast wave and a crater. The asteroid fell into large stalks of flammable materials. Simply put, the space rock got into a giant vat of combustible substances. This provoked a drop of millions of tons of soot and ash into the air. The fire quickly spread throughout the island, emitting black smoke into the sky. Dinosaurs living hundreds of miles away from the site are getting nervous. Feelings of anxiety are growing. Their inner instinct of self-preservation signals that disaster is coming. The sky becomes gray and darkens. Black clouds cover the sun and reflect the light. However, these are not just regular clouds, but volcanic ash. The asteroid fell at the most destructive angle. It also hit the coastal part, so the destruction reached the seabed filled with sulfuric acid. And now it's all coming out. Toxic fumes get mixed with incandescent ash, soot, and metals the meteorite contained. A fiery hot cloud emits acidic smoke that is very harmful to health. And this cloud, driven by the winds, grows and stretches all over the continent. It's getting cold on the ground. Plants, grass, and trees are quickly withering. The green valley, saturated with life, becomes gray and lifeless, which leads to an imbalance in nature. Most dinosaurs can't get fresh grass and leaves. This problem also affects predatory reptiles since the number of herbivorous lizards significantly decreases. Animals start to freeze and starve. They move away to search for some food and find a warm place, but it's too late because a poisonous firestorm is approaching them quickly. Dinosaurs try to hide in burrows and caves. Some lizards are looking at the sky, which is getting darker each second. A tiny sparkle slowly falls from a black, fiery cloud. This is a particle of hot ash. It drops to the ground, touches the dry leaves, and sets them on fire. Millions of such particles fall to the ground. The forest flares up like a match. The smoke from the burning trees rises and becomes part of the expanding ash cloud. The more the fire spreads, the larger the ash cloud becomes. Sulfuric acid vapors mix with molten metal particles and fall to the ground as poisonous droplets. Acid rain corrodes vegetation and poisons the soil. Flying lizards rise into the sky and enter the center of the firestorm. Dinosaurs on the ground are running from the forest towards the water, but it's impossible to escape from the apocalypse. The scale of the disaster is increasing exponentially. While acid rain and firestorms destroy one part of the continent, the coastal side faces another problem. The fall of the meteorite caused a giant tsunami. It hits the shore and floods large areas of land. After the massive explosion, the first wave forms. It could quickly destroy modern-day New York. A series of smaller waves, the size of a 5-story building, sweep across the Atlantic Ocean and the North Pacific Ocean. Giant tsunamis are not so scary for deep-sea dinosaurs, but the poisonous cloud poses a danger to them. Particles of sulfur and ash cover the sky above the water surface and bring down poisonous rain. Seaweed and phytoplankton don't survive it. Thus, millions of fish face the threat of famine. This causes huge problems for the whole food chain in the ocean. Giant sea lizards can't survive either. The meteorite created a domino effect that put the entire continent under threat of extinction. A few weeks have passed. The ashes have settled and cooled down. The fires are over, and the air has become cleaner. The sun is finally peeking through the clouds. But the planet looks different now. Giant lizards don't exist on the planet anymore. Green forests have turned into gray fields. Fortunately, not for long. The seeds of plants and trees have survived the apocalypse and are now blooming with renewed vigor. Nature is filled with colors again. Little creatures similar to rats have been hiding in the ground and have also survived, and now they finally get out to continue spreading life. It wasn't firestorms, tsunamis, fires, and lack of sunlight that destroyed the dinosaurs. The primary damage to the world at that moment was the disruption of the food chain. All big herbivorous dinosaurs and giant toothy monsters lost their food sources. Small animals and some flying dinosaurs survived to further evolve into modern birds and mammals. Large animals, the size of a rhinoceros, appeared 15 million years after the disaster. Tens of millions of years passed since that moment, and then humanity appeared. Thanks to modern technology, we've discovered the reasons for the destruction of dinosaurs. We don't know every detail, but we have a common picture of those events. And the scariest thing is that if the same asteroid fell again into some explosive terrain, we wouldn't be able to do anything about it, and our remarkable technologies wouldn't help much. Yes, we might disperse ash clouds and extinguish some fires, but it would be insignificant. Floods, fires, and acid rain would make life in big cities unbearable. The only thing that would help us survive could be underground bunkers and other reliable shelters. But how to survive the famine that would come after the destruction of vegetation and crops? We are developing and improving technologies that can protect us from asteroids, like lasers or space rockets with explosives. But even if we destroy one big rock, it might tear into a million pieces. Some will burn up in the atmosphere, and some will fall on the planet in the form of a meteor shower. Anyway, we'll face huge natural disasters. Therefore, all we can do now is hope that no rock from space will come to us.